Okay, welcome everyone. I'm going to start today's session. So do let me know if you have any query during the discussion. So we will do the Python software-based data analysis, and our context will be panel data. So we will be only focusing on what are the common challenges in today's session. The first part, we will focus on uh, what are the basics of importing data, how we can visualize, and what are the basic visualization types available, how to run simple panel data regression, and some other forms of panel data regression. So we will focus mainly on uh, static panel data models, and then we will learn to make dynamic panel data models in the next session. So today we'll focus on to make it a 2 and a 2.5 hour session, and we will have breaks during the session, and then we will join again using the same meeting link. So we'll start with Python. So you have to open Google Colab using searching Google Colab here. When you open Google Colab, it will ask you your username and password for your Gmail account. And when you add your Gmail account, so you will have, if you already have done some coding before, you will have sample files. Otherwise, what you will do is you will open a new notebook. And if you have my link that I have shared, if you can click it, it will show you my notebook. But if you make your own, if you want to make your own, you just click a new notebook. It will open as a new file. Okay, so in this setup, it will show like this. The advantage of this method of doing Python is that it is directly connected to AI rather than using any other platform that are available, which are more maybe more user friendly or more detailed. This is simple platform, and this also can be used for R. So if you want to use for R, so by default it is set for Python. If you want to use it for R, you can go in runtime and change runtime type, and then from Python 3 to do make it R. So you can change it to R so that it will run for R. And in this platform, I will first of all give you overview. This button will be used to when Python is connected, it will show here. Okay, and so it's when it is connected, so you will see how to open files. So you can upload your files in your Google Drive, and then you mount the drive and read the data from your Google Drive, or you can temporarily upload the files here. So if you upload the temporary file here, it will show here in the later on today I will show you. And this is your background. Anything that you create, a new data file or a new graph that you save, it will be shown here. And then if you click here, you can download it, or you can write a code that can help you to download the file. We will cover that part during this session and the next session. So this is a file session, and then what you can do is that this way you understand the platform. You can change the file name from here, whatever name you want to keep, so that you can open it up later on. And then now I will open up my file. How I do it? File, open notebook. So it will tell me which one I need to open. So I will start with loading datasets. Okay. So this is my data file. So you can go in Google and my in the Google class, and you can get this link. I have shared this codes in that file. So I will slowly go down and discuss the codes. And if you want to ask about any other way to do something, like if you want me to do some new thing that you want to see, we can do it together by on the screen. Okay, so this is the dataset. So how you load the dataset, I have already shared in the Google class. So I will open up the files and let the Python to connect first. When it is connected, you will see the folders. I will open up, and in my shared folder that I have already shared the files, I will load the data files. I don't need the first one because it is not in this example, but I will upload the rest of the files like this. So since we are learning how to load the data file, so I have added a CSV file, Excel file, SPSS file, and Stata file as an example to learn if we have data from other source or other software, how to import in Stata in Python. If you have any query, do raise hand. So firstly, whenever we need to do anything, we need to load the library. Just like in Stata, we install the library. In R, we install and then load. In Python, it is usually install and then load. But in default, some of the libraries are already installed, like pandas. And if let's say if you, I will show you examples. Let's say if you are trying to do the data management, you need to manage the data, like you need to transpose or load or read or describe any data management type. The library that is known as pandas. Now you can directly import pandas without writing as pd, but the difference in Python and R is that in Python, any function that you want to run, you need to write the library name before it so that Python knows that this function is coming from that library, because there are so many functions and so many things that Python can do, it cannot remember which library it is from. So I will let you know more details later on. So I import the pandas and write a short name for it. So import pandas as pd. So when I run it, it took 0 seconds, and then the library is loaded. If there is an error, it will show it here, and the tick means all the codes are properly executed. There was no error. Next command is data. I need to load a data, and I will name it data equal to pd. Now pd is coming from here. Pandas dot read underscore csv. So read underscore csv is the function that we are executing, and if you hover a mouse, it will also give you details if you want to know. Okay, so it is explaining what does read CSV can do. But Python has so many functions, it does not know from where read CSV is coming from. So pd.read. See, if I don't add as pd, I have to write pandas.read. So some libraries names are so big, so we try to make it short name. So pd.read.csv and only the data file name. How do you know it? You already loaded it here. So I wrote the same name. If it is in your you need to make sure the names is correct. So when I execute it, it took 0 second and data is loaded. Okay. So if there is an error in loading the data, you can get it from you will see it here. So we will see some examples of error and how to solve it. So if you want to see the one of the issue of Python is that sometimes data is so big you cannot see all the data, and unfortunately Python does not have an Excel like parallel platform which is as easy as Excel, so that you can open the data file anytime. You can download the data file, but if you want to do any amendments and you want to see, you have to save it first and then you see. So if you want to see the head means first 20 rows. So head, if I only write head and no nothing in the brackets, it will show first 10 rows, but I wanted to see 20. So data dot head and 20. So it show when I execute it, it will show me first 20 rows of the data. Python, the numbering starts from 0. So if you say first 20 rows, it will be from 0 to 19. So Python numbering is different from R or Stata, where the numbering starts from 1. Here the numbering starts from 0. So you need to understand, if I say first row, it means row number 0. Second row, row number 1. So it's actually one less. So this way you can view the data. If you want to go more detail, you can just click this button, okay, and then you can explore more. So you can go beyond and see more data. Okay, so this way you can play with the data and understand how what is the nature of the data. And you can apply filter, you can apply further functions, and you can see more rows. If you press this, and it will show you more rows. Okay, and then it can also suggest you, so it will open a new platform. We will discuss that later on, but this platform is not a coding based. It can help you to suggest you how to make charts, but in the next sheet we will work on it. Okay, now if you want to see what are the properties of the variables, Python has one command, print. So if you write print and within bracket write something, it will print that thing. But if you want to show it as a, so if you write this, it will come like this table. But if I want to show it as a table format, not a text format, so you add a new line here, new line code, and then paste. Rather than print, I remove the print part, and then you can see it will show similarly because it does not have other format. So if you want to describe means descriptive stats, so print data.describe, it will give you that like this. But if I want to see if it has a other format, other table format, I will go here, and then rather than print, I will only write data.describe. So when I run it, you will be able to see a table format, and then you can open it and see more details. So this way you can load the CSV file and then see the data properties. In my case, all of them are the countries and object, others are numeric. So integer, float are types of numerical variables, and there are no missing values in it. So this way I can see the properties of the data. Now I wanted to see if I can upload the Excel file. So data pd read dot underscore Excel. So it will read the Excel file. So since the name is same, it has overwritten on the previous file. And now let me remove this one first line, and then add it in the middle. So you have noticed that there is one comment file. You can add it by add a text. This way you can add a comment in your document so that you can see here something has changed. Now if you go down, I wanted to load the SPSS file. For that, I need to load this library import pyread.stat. So this library is a part or extension of pandas. That's why I don't need a short name, because it will just connect with the pandas and you will use the PD again. So when I run this, it will give me an error. So need to understand the error that there is no module name pyread.stat. So if it is in the import, it means you need to install. So you can install it using this command. If I add this not sign before, see, so it will, this is used to install it only for this time. If I remove it, it will install it permanently. So it's up to you what method you want to use. But if I run this now, it will install this library in the background. So it will say successfully installed. If it is installed, then when I run it again, it will load the data file. So this way you understand first type of error when the library that you load is not functioning. Okay. Next is import the stata format. So it is simple, pd.read underscore stata. So this was the first part where we understood how to bring the data into Python. So we can go back again. And so if you have a link to the Google class, I've already shared the link to this library. What you can do is when you open the link, you can um, copy save a copy to your drive means you can move this code in your library so that you can do it again, or you can open your own Python library, Python Google Colab, and copy the codes or type it and practice it for yourself. So if you have questions here, do let me know. Otherwise, we will move towards the second part, that is visualization of data which is already imported in the library. Please raise hand if you have any question. Yes.
Assalamu alaikum, sir. Sir, my
Walaikum.
question is that do we need to im write down this import? Do we need to import all the libraries again and again, or if we know what libraries would be used in analysis, we can import them at once, like we do in R?
Yes. So we will import all of them, but in the first line, all of them in one go. But since we only knew only one of them, we in this file two of them were loaded. So this command import by stat, you can cut it and import it here together. So usually people load them together. So they make a heading importing libraries and load all the libraries in one time. The advantage of this is that if any of the library has an issue, maybe it has been updated or maybe some of the function has been removed, like you are loading a library within, so you can import a sub library also. So let's in the next file I will import a sub library. Sometimes the spelling or the name of sub library has been changed. You will know here that this library does not exist anymore, or its name has been changed. So you correct it in the start rather than you do all the work and you find out that this library is not working, and when you find an alternative library it has a clash with the your existing library. Means there are counter libraries that can do similar work, but then you have to amend the code that can match the work. Okay. So this was the first part, and then we focused on importing the data, and then little bit of descriptive stat where we got mean, standard deviation, minimum, percentile values, and maximum. So if you go need to go further, you need to we will see that in the coming sessions. Okay, and anything that I remember here is you can do more things here, like I showed you info. You can also add another line like uh, data dot columns. This will show you the variable names which are loaded. So if you want to don't know which variable is loaded and which is not, so here you got the variable names. So uh, here I will go through it later on. So let me load the data. So it is loading the data which is different from this because I when I loaded the stata file it has different variables. So let me import the CSV file again, and then when I show you data.columns it will show you the variables which are there. So this has the advantage that if your data variable names are long, then you can just copy them and use them in the code. So this was the first feature. So before going forward, we can now I will tell you the advantage of using Google Colabs. That is that you also have AI embedded in it. Let's I wanted to create a square variable for C. So what I will do, I will add a code. So you can see a start coding or generate with AI. So I will press generate with AI. AI, I will write, I need to generate a square form of C variable in data file. So it will suggest, if you press enter, it will suggest you the code. The advantage of this AI is that it can read your previous codes. So it will know what you have already done, and then it can suggest you. So it sometimes gives you too much codes, okay, and you don't need most of them. So it means in this file I don't let me see if I've already given the answer. Yeah, so this is the correct code. So there was a confusion here because the data file and the data as a data file Python didn't knew. So I will remove the useless codes, okay, and then I have found the code that can generate the. So you how you generate the code, that is data, uh, data and column square brackets and the name equal to data variable that you want to use to generate, and multiply square. So double multiply means power here in Python. So when I do this, it will generate the variable. And if you want to see it, you can just add data dot head bracket open close. So you will see that she's good. Yes, you can ask question now.
Sir, how do we check the validity of the code given by AI? As while working with R, I had the similar issue that if we run the same function in Stata, the answer would be different, and the code that I got from Chat GPT, it gave me quite a different answer. So, how do we check the validity
Okay,
of it?
for that, you need to, first of all, you need to have a basic understanding, just like theory. Here, the basic understand what code it is running. So it has just generated a square. So that will not be different if you do it yourself. Or so if you are trying to generate something complicated and there are several steps, so I would recommend here, don't ask all the steps in one, because it's you can see here in the my process one small step in one row, so that I can see what is happening and then going above. So sometimes error comes when you ask too many things, and then if there is an error, so if there is an error, it will show error. And so if let me write something and that can give you an error. So I will write data. I need to make a new variable that is log of y. So I don't know how to take a log, so I will just write a random thing. So log of data, and I need to use the y variable. So I'm just checking if y variable can be converted into log. So when I run this, it gives me error. So the advantage of Google Colab is you just press explain error. It will tell you what is an issue, and it will suggest you the alternative. And you test the alternative until you are satisfied what outcome that you need. So it said that the for log you need to import another library that does the mathematical operations, that is called NumPy. So I will copy this part and I will paste it here. So I will load the NumPy, which does the numeric mathematical operations, and I named this NP. So log of y is equal to NP dot log and data y. So this way, and then when you done it, you can just write data dot head again. Any output, I skip shift to a new line when I have a new output. That can be a graph or a table. So here the output is a table. So I can see the log here. You can just check, convert, take a natural log of this value, see if it is same. It means it has been sorted. Okay. So this way I check it. Yeah. So the issue can be when you are applying a complicated. So try to break it down into smaller version. Okay, so that you can check it and verify, just like I'm doing. I'm printing it, or in the next part I will be making graphs. Any other question from this part, or otherwise we'll move to the next part. Okay, so this was the part, and You can, since I have given you the link, you can see the updated file. Okay. So let's go to the next part. File. I will open the new file. So open notebook. My next file was data visualizations. So I will focus on some of the graphs before we go towards the regression analysis. Okay. So for the another advantage of this platform and other platform also have this feature that if they recognize the text and the code and they color it properly. So, and the comments. So you will see if you write import and if the spelling is wrong, it will not make it purple. So I'm importing pandas as PD. It will be for data management. Seaborn is for making graphs. Matplotlib is also for graphs. Both have some differences, but mostly both are used in. And when you use this command, it helps you to view the graphs here. And so when I run this library, if your Google Colab does not have it, then you have to install it. I've shown you the code. I will give you example. Let's say in your Python cborn is not installed. You will write pip install cborn and then run it. It will install it in your Google Colab or any other platform that you use. In the next week, we will focus on. I will also show you the VS Code so that you can, if you want to run Python offline, you can then use it. Now for the graphs, I will load some already ready-made data set which is available in the Seaborn library. So I will just save them. So tips is the data file for categorical and numerical data, and fMRI is the data for time series data. So these are some sample data sets and you don't have to upload them. They are already there in the Seaborn library. Just I am loading the example data sets. Okay. So these data sets are here. I want to view them. So what I will do, tips.head, I will be able to see the data. So it is the data for people who tip and they bill and the people who this is the data for people who attend data for people who pay the bill for the dinner or the lunch. So it is the transaction data and the nature of people. Okay. And if I wanted to, so these are only variables. If the variables are many, you can see using tips dot columns. And if you want to see properties of the data, you can use what you call it, the describe command. So first of all, we'll see this function. So I will press this. It will tell me. So it has suggested you some graphs for the variable. So it showed you the distribution graphs. Okay, so it start with one. It has not used this variable, the gender, because it's the it is not a numerical form. So it has skipped this variable, but it has given you distribution for other variables. It has showed you the scatter plot. It has showed you the time series. So it has only suggested you what can be done. Next is we'll start with examples that I have here shown here. You can make a scatter plot. So usually in Python, the commands for graphs are somewhat detailed, just like in R, but it has a new line for each function. So first of all, you describe the figure size. It should be a rectangle or a square. So I said it's 6 by 4. It means it is 6 units wide and 4 units high. And then so PLT comes from the matplotlib. So it has made a frame. Okay, let's continue and we will discuss it slowly so that everyone can catch up. So we were talking about making graphs. So first part of graph is that it is plt.figure and then you add a figure size. This sets the frame of the graph. If you want to make a rectangular, if you want to make a square, you may write same numbers. Okay. So 6 by 4 means it's 6 units wide and 4 units tall. And then SNS means seaborn. And then you apply scatter plot. You pick up the data file, you add a x variable and a y variable. If you want to add a color because of the any third variable, and if you want to add a style of the dot because of the fourth variable. So it technically is a four-dimensional graph. And then you add a title and then plt show. So when I run it, you will see that it is a rectangular variable. It has four dimensions. One is shown as x and y, two variables here. One as a time means lunch or dinner means red and blue, and the other is gender, which is male or female. So you can see it's a four-dimensional chart. If you want to reduce, if you don't have, you can just remove this or remove hue. There's a third type you can add if you want. If there is another variable, let's say if you want to, yeah, size. So you can just add a size variable here. Let's try size equal to size. It's the size of the family or size of the people who came for the lunch. So you can see another dimension here. So there's a pattern in the scatter patterns because of tip and total bill, and there's a pattern because of the color, which is showing the lunch time. There's a pattern in terms of size of the dot, which is showing the number of people who are in the food eating. Well, it was a lunch or dinner, and then gender. So it is using circle or cross. So this way it's more detailed. So this way you make this graph. And if you want to, let's say you want to improve it further. So let's say I need to get help from AI to make it improved. So I will press this button, explain the code. So it will tell me what does it code do. I will tell him to uh, it will explain all the lines if you don't understand any of the parts. So this way you can go in detail and it will tell you what each line does. So I need to export this graph in 300 dpi TIFF format. So it will tell me how to export it. So it will tell me that how to add. So it has added this line, extra line. So if you add this extra line, if you just copy it and add it before here. So when I run it, so I will just close this. It will show the graph and it will also tell me that the graph is available for, it's available here. And let's see, yeah, it's available here. So if I just download it, so everything that is shown here, when you close the Colab, it will be deleted because it's a temporary folder. I will open the graph. So now you can save it in your for downloads and then move it in your graph Word file. So you see this graph, so much detailed. So it's because it's a 300 dpi graph. So if you save it, uh, so you will see that, let's say if I open this folder, you will see the size of the file, it's 8 MB. So it's big enough. It's already high density graph. So you can make it more bigger by telling him to make it 400 dpi or increase the figure size. Okay, so this way you can improve the graph. Next is the box plot for variable. So if I show it first, then we'll discuss. So it is made across two dimensions. So it has a day as a x-axis and bill as a y-axis. So it's a data, and for each day, the technically box plot is shown, and then across the gender, it has changed it. So this way you can see it's again more detailed. So you can, if you want to remove this gender, it will show only, and then if you can also remove the day, it will only show one. So let's copy it, and we want to go one step up and make it more simpler version. So I will just remove the gender variable, and then I don't want to show day wise. So if I show it only one variable, so need to update the title also. Okay, so this way title is it. Now I need to improve one more thing. So we will do add details one by one in this graph. Next thing I want to add is I need to add a label on y-axis. I need to know how to change the label. So it will tell me how to do it. So it says that plt y label. So if I copy this and add it here, so total bill amount rather than total underscore bill, you can just add more details, total bill amount. Okay, so this way you improve the graph. Next we go, we want to make a violin plot. It is similar to box plot, but it has some other features. So let's make it first and then I will show. So it has a box plot in between, but it is showing a distribution of both. So the distribution plot sometimes picks up more things than a box plot because box plot only focuses on between the first quantile and the third quantile, and it does not about talk about the distribution. It is same thing like above, but it has a distribution. Now you can remove the gender. So rather than hue, if you go up and if you want to pick some other variable, let's say smoker. So rather than gender, I will pick smoker. So it will make it pick up based on smoker. Smoker yes or smoker no. So this way it has shown me a distribution. Okay. So it has we note that the shape of the data. So if it's a panel data, how you will pick it up? So if you have few countries, you can move countries here and make distribution of the very dependent variable here. And if the country has to, but this part, if the country has a structural break, you say before event or after event, so you can see how distribution has changed. So this way you can edit for panel data. And then for the scatter plot, you already know your DV and IV and then control variables. You can make your graph like this. And then we go for tree plot. So when I make it, it is similar to histogram, this violin plot or box plot, but it shows like dots. Now you can change, remove the gender or remove the variables so that if you want to show fewer points. So and I need to add more details. Like what we can do is uh, I I need to make it black and white print competitive print read table graph, because when you print it in black and white you will not be able to distinguish between male and female. So what does it say? So it let's go down. So it says that let's see example. So it has said that you can for the strip plot, let's see, it has given an example. Where is my command? Let's see. So if you go down, yeah, so you can have this palette grayscale. So if you copy it and add it here, and if you want print it, it will be black and white, but the shade is not picking up. Okay, so what you can pick it up is that you had to, rather than hue, you can pick from here style. So you come down and change from hue to, so that rather than color, it has a, so it gives the error. So because the style has not been picked up, so we'll ask him to explain the error. So let's say how does it give you a solution. So it says that, so it says that rather than hue, you use the dodge. Okay, so I will copy this code and replace everything here, and then it has slight change in color, but you need to we will find more solutions in the coming graphs. Okay. Then there is a swarm plot. Let's say what kind of graph it is. It is making a scatter plot, and it's more like a distribution. So here still the problem is that it is making it black and white because it is picking up from here. So first of all, I will I need to reset the palette type so that it is different, and then I need the first of all I will learn this how to reset in this graph, and then so this is the graph, and from gray, so reset defaults. Okay, so I will add a command here to Z, copy the default, and then make the graph. So it will be again colorful. Okay, so this way you can show now. So for your understanding, within a panel data, how does it will help? So let's say you are doing research on BRICS countries. So you will have 5 BRICS countries and a dependent variable shown here. And then if your dependent variable, you want to compare it with some qualitative independent variable, maybe before COVID and after COVID. So you will have a dummy variable COVID before and after. You will see how the distribution of the dependent variable is changing before COVID and after COVID. Okay, or maybe deep democracy or dictatorship, 0 1 variable. So, but if it is a continuous variable, you use scatter plot and add a size for continuous. But it will also work for a discrete ordinal variable. Okay, and then we go for, and there's a bar plot. How does it look like? It looks like a column chart. Okay, and then it is for both genders, so you can, rather than sex, you can add smoker. Okay, so and you run it to show for smoker, yes or no. Okay, then there's a plot of count plot. What does it look like? It is similar to this variable where, but here it's the mean, here the count, number of observations. So so that's the difference in these both graphs. Okay, and these are all univariate, means only focusing on one variable as an outcome, but you are splitting it into different versions. If you have any questions here, you can ask. Otherwise, first of all, I will complete the graphs, and then we'll talk about our example and try to make some example graphs. Okay, let's move forward. Next is distribution plot. So you can make a histogram of a variable, and then this histogram is shown here. So then you can make, if you want to make histogram with more variables, then we will see later on. Then there's a rug plot. Okay, it's like a histogram, but it is shown like this. So more density, more thicker lines. Okay, so these two are for distribution of our data. Then there is a multivariate. We start with a scatter plot of two variables. We have already discussed it in detail. So here I added a size here. So this is now multivariate. So there is a continuous variable here. Okay, and it is already discussed above. And then there's a joint plot. I usually like this one, and this the eViews has also tried to add this feature, but not very much in detail. But in Python, you can do it quickly. So you can see there's two variables, and there's a scatter plot between two variables, and then there's a third variable which has changed the color. And I want to see the distribution of this total bill based upon time. So its distribution is here. It's a univariate, and for tip, the distribution is here. So you can see it's you are already comparing two variables by adding a third variable, and you're also looking at the distribution of the two variables on x and y axis based upon the third variable. So like you want to add a moderator, so you can check how moderator is playing a role. So you can see the distribution is changing and the scatter plots is a little bit lower, the orange ones. So the moderator has somewhat negative effect. So this way you can explain. Okay, so how the code works? So it's a joint plot, dependent variable, x variable, y variable, and the type of the graph in between, and the contrast variable, the third variable, and the margin ticks. So if you want to add the margins, ticks, yes, true. And then what kind of graph you want to make? You want to make this graph, so it will make a distribution graph. Okay. Then there is a pairwise scatter plot. So what you want to do is SNS plot, and you have the variables. Let's run it first of all and then see what kind of graph it is. So what does it do? So you have all the variables. So it will pick up the continuous variables. So the variables include size, tip, and total bill, and then the binomial variable as a contrast, and then it is showed that how tip and bill are related, how total bill and tip are related, and then size and bill are related, and then the gender as the contrast. Okay, so this way you just shown the association between variables in a very interesting way. So you if you remove the hue, you will make it simple if you want to add details here. So next is the correlation plot. So first of all calculate the correlations. So it is said that one of the variable is not a numeric. Okay, so that's why it is not running. So first of all, I will ask him to explain the error. It means we have to remove the variable. Which one of them? Let's see. So it says that it only need to pick a number. So if I copy this, only numerical variable will be selected. Okay, only include the numerical variables. Okay, so
अस्सलाम वालेकुम सर.
Walaikum Salam.
हाँ जी सर, मेरा एक क्वेश्चन है. Sir, I have experience of doing this kind of scatter plot with continuous variable, continuous
Hmm.
IV and DV variable.
Hmm.
लेकिन सर उसमें प्रॉब्लम मुझे ये फेस करनी पड़ती है कि जैसे ये लीनियर रिलेशनशिप शो कर रहे हैं ना, इस तरह
Hmm.
नहीं आता ग्राफ. मतलब वो इस तरह जैसे सीधी लाइंस में ये साइड पे राइट साइड पे है ना, इस समटाइम इस तरह अपीयर होते हैं, या समटाइम इस तरह ऑल ओवर द एरिया जो है वो स्कैटर होते हैं. सर उस सूरत में क्या हमें मतलब क्या प्रिकॉशंस करनी चाहिए? इज इट गुड टू गो फॉर दिस काइंड ऑफ रिलेशनशिप, और
नहीं
क्या
देखें,
मतलब
इसका
कोई
इसका
सोल्यूशन?
तरीका ही होता है, जब जब डेटा बड़ा होगा तो डेफिनेटली स्कैटर प्लॉट भी स्कैटर हुआ होगा. ठीक है. सो उसका सोल्यूशन
ओके.
ये होता है कि फर्स्ट ऑफ ऑल अगर तो डेटा में क्लस्टरिंग हो रही है तो इसका मतलब है कोई आउटलायर्स होंगे किसी एक एक्सेस में, कि भी डॉट्स दो तीन एक साइड पे हैं बाकी सारे एक तरफ. देन ट्राई टू सॉर्ट दैट आउटलायर्स फर्स्ट, ताकि डेटा में पैटर्न नजर आए. सेकंड थिंग होती है जो यहाँ पे बताने की कोशिश की है कि इफ डॉट्स आर नॉट शोइंग एनी पैटर्न, देन यू ऐड अ थर्ड वेरिएबल और उसे कलर चेंज करें या साइज चेंज करें और शेप चेंज करें, एंड देन यू फाइंड एन पैटर्न. अदरवाइज समटाइम्स व्हेन द डॉट्स आर टू मैनी, स्कैटर प्लॉट विल नॉट हेल्प यू. उसके लिए फिर कोरिलेशन मेथड ही यूज
ओके.
किया जाता है न्यूमेरिकल में. ये तो स्कैटर प्लॉट
ओके
विल
सर.
नॉट वर्क. स्कैटर प्लॉट उस टाइम
सो
वर्क
इट्स
कर सकता है कि
बेसिकली,
यू
या
आई विल गिव यू वन मोर एग्जांपल हेयर. तो वो वो तरीका मैं यूजुअली कर लेता हूँ, या इन मोस्ट केसेस मेरे वाले मॉडल में कोई ना कोई मॉडरेटर भी होता है, तो आई ट्राई टू मेक अ स्कैटर प्लॉट बेस्ड अपॉन मॉडरेटर. फॉर एग्जांपल if the let me just talk about this example here and then we will continue. ठीक है, तो दो एग्जांपल्स हैं, आई विल
यस
ट्राई टू
सर.
ऐड इट here. Okay. So we discussed up till the scatter plot, and then we tried to add as other plot. So I updated the code so we can make a correlation scatter plot like this. So it will color based upon the correlation value. The limitation of this graph is, first of all, there should not be any missing values. So you have to make sure that missing values are removed and all the data are numeric so that you can calculate the correlations. Okay, now we'll go beyond, and then I will try to add another example. I will pick up this simple code. Okay, I will copy it, and I will try to add more examples in it. So I will come down and generate with AI. I want to add a linear fit line in this scatter plot. And when I paste it, I will just remove the size variable because I don't need size and hue. I only need simple. So I will press enter. So it will load, create a graph here. So sometimes it gives you extra codes because um, it is not able to pick up the boundary. So this already done, pair plot already done, this already done, remove it. And distribution plot already done, remove it. And I need to go up and let's see where it has shown the graph that I wanted. So it has not given me the code. So the prompt has not properly worked. So let's remove it. How to add a linear fit line in the scatter plot. So it will, yeah, this one. So we'll remove the other codes. We don't need them. We'll start with scatter plot. Okay, and there's a linear field line. I don't need the remaining codes. Delete and delete. So these are the codes. So first of all, run it. And then it says NP is not defined. So I will add the library for NP, and it will be, it has shown, it has maybe loaded here. So it's import and numpy as MP because I have to calculate the square. So there's a mathematical function here. So import numpy as NP. So I will run it again. So there's no line here. Yeah, so there's a linear fit here. So it means there are two graphs showing up here. So you can see in this graph. So I will remove the extra things. I will remove size and hue, yeah, all of them. This is the scatter plot. And then, okay, I will run it again. So you see, so this line will give you a view if there are too many dots, and then you are able to see the pattern using the linear fit. Second method that I can use is if the I have a moderator, uh, or I can just add a square form of this variable, quadratic fit, if I wanted to add a quadratic fit. So make a quadratic fit graph in the quadratic fit line in the scatter plot. Yes, you can ask the question if you want. So
अस्सलाम वालेकुम सर, मेरे से लॉगिन नहीं हो रहा, मैं थोड़ा लेट हो गया। मुझे ये बताएं
yes,
इसे लॉगिन कैसे करूं मैं गूगल
uh,
मीट से।
if you are not able to log into Google Class, just write in the group, and I will share you the link. And if you are logged in, then in the Google class, there is a link for this code, and you have to open Google Colab. Got it? And if there is any query, you can just write in the group, and I will try to send you the relevant link.
Sir, basically, I want to open it on my laptop because I have joined it from the phone, but I ain't able to join through the laptop because it will be convenient for me.
So if you want to join, what you want to join, what you are already in the meeting.
I want to join through the laptop because I have joined it through
So
the phone.
the
It's not feasible for
meeting
me to see.
invitation is there in the WhatsApp group. So you can just copy the link, open the WhatsApp web in your computer and join it, or just copy the message, email to yourself and then join it.
Okay, okay. Thank you so much, sir. Thank you so much. Thank you so much. Sorry for interruption.
So this is a quadratic fit, and you see that there's not much bend because there's no much nonlinear association. Third type that I use is that I pick a third variable, which is usually a moderator, and tell him to make two lines, one when the moderator is below average and it is above average. Okay, so this way you can add two graphs. Okay, so I will try that graph. Make a scatter plot between tip and total score bill and show the linear near fit for two cases. One when the I need to pick up the numeric variable, so I will pick up the numeric variable as size. So when the size is below average and when size is above average. So I am trying to make a continuous variable as a binomial and then relate the relationship between the graphs. So the useless because the libraries are already loaded. So data set is already loaded. So first of all, I will create a average and then create two variables below average and above average and then plot this graph. The plot two graphs together. So let's run it. So two simultaneous. So you can see the slope, the intercept and slope. So in this case, the intercept is smaller, intercept is bigger, so it means it has shifted up. But its slope is smaller, means it has shifted up, but it has also flattened. So this way, I can compare the effect of the third variable on the relationship of the two variables. So this way, you can visualize the moderation effect using graph. Okay, I think this was the case that you tried to discuss, that the dots are not showing any pattern. This way you can add patterns. In the third part, now we go towards the time series charts. So I will loading the fMRI data. So this is the time series data. I will pick up example of a line chart. So PLT figure, so it has made a horizontal table more wider because I need to show more time period. So it's a time point and this is a signal. So this is one time series data and then I convert it into two further types. So time series, so you want to plot the GDP growth, then but it is a panel data. So you plot up GDP growth across time, but you average them based upon some other quality. Okay, so this way you can show how GDP growth changes because of independent variable. So for that, there can be many examples. Like you say, GDP growth for developed countries, average across time, and GDP growth for developing countries, average across time. So you will have two time series charts made from the panel data. Okay, so when we load the panel data in the coming classes, we will try to discuss that complicated graphs. And then we want multiple column chart. So what I did, I picked the data and grouped it across days. So we already discussed above. So it's a column chart. And then we have, I have loaded another data. So you have to load it here. So csv.read, I will load the CSV data. This. Okay. So when you load it, sometimes say that make sure you don't delete it from your computer because this file is not permanently uploaded. Okay, and now when I read this, it will read the data and show you the variables. I need to calculate from this panel data. I need to make a year averages and make a time series chart. So what I did, I converted into year averages and then I made a time series plot for two variables. So it shows that across the so consumption is falling across the years and incomes are increasing. So it means people are able to make either the goods are becoming expensive or people are saving more. So for that we need further investigation. Okay, so this way you can show a time. So it's a time series chart made out of panel data. So what you can further do is that if there is any discrete variable like developed or underdeveloped, you can make two time series chart for blue and two for the orange one. Any questions here? Do raise hand. Otherwise, I will move forward.
सर मेरा क्वेश्चन ये, क्या इस रिकॉर्डिंग की इसकी वीडियो की रिकॉर्डिंग भी मिल जाएगी?
Yes, I will share in the group.
थैंक यू सो मच सर.
Okay. Next is that I wanted to convert it into country-wise averages, how other countries are showing. So I will convert the data into country averages. So this is country average data, and I want to plot it. So this will be a bigger plot because there are too many countries. The challenge is how to show it. So I will talk about it. So axis grade, I need to reduce the font of this x-axis. Yes, you can ask the question. Meanwhile, I will show how to reduce the font of x-axis labels. So it is, yes.
Sir, in the previous diagrams, there were some outliers. So if I want to see how the outliers are impacting the chart or my data set, and I want to first plot the data as it is, and later without outliers to see if the pattern changes. Can I do that also? And for that purpose, how should I modify the code?
There are two ways. First of all, you need to understand which one is outlier. So what you can do is you can make a dummy variable if the data is outlier or not, and make a new data in the Excel file, and then either filter the data and just do make a graph on non outlier data, or what you can do is, let's assume that this observation is an outlier. So what you can tell Python that you draw the tip data which is below 10. So it will exclude this observation and then draw it. If you draw up till 8, it will remove these two. So this is the way you remove the outliers if you want. But if you want to, but it depends if the outlier is actually an outlier or not. It depends upon the standard deviation of the data. First of all, you need to apply other tests to confirm if the data is outlier. Okay, then you do anything that you want to do. Yes, here it looks like these two are outlier, but maybe the scale is not that clear enough. Yeah, they look like outlier, but in this case they are not. There is not much outlier because the distance of this dot from this line is same as this dot from this line. So technically no outlier in this case. So that you have to do judiciously. So we were talking about this graph and I wanted to reduce the font size. So I asked to the Gemini and it told me that if I add this, so I already add the rotation 45 degrees so that I can see the names, and I will just add another line, comma, font size equal to 8. I reduce the font size. So it's reduced. So you can further reduce it if you want. So this way you can make the graph. So up till now, but we have discussed two things. We'll open up. So in this session, we talked about how to make graphs. So we gone through the library and you can also access this code file and execute it yourself to see how graphs are made. Okay. And I also talked about how you can modify the graph using help. So if you are writing a new line, you can directly ask using AI. If the line is already written, you can go using this Gemini and explain the code and then ask it. And the third method is if there is an error, then there will be a button explain the error. So this was the this part. And the first part that we discussed in the start was, I will open that. So open the codebook and loading the data. So I will first of all save it. So it is saving the file. Yes, it is saved now. So open the notebook and I will open the loading data set. The first session, what we did was, let me close other links. Yeah, what we did was we learned what is meant by pandas and how to load the data file. In the example, we learned how to load the CSV data. This is the code, how to see how many observations are there, how to see the properties of the variables, how to see a number of variables in the data, how to see descriptive stats. Okay, two ways, one as a text and one as a table. Then how to load the Excel file, and then if there is some library missing, how to install it, and how to read an SPSS data file, how to read a stata data file, and how to generate a square variable or a log variable. So when you get the recording, you will understand, or if you already have the link for this code file, when you open it in your computer, you can execute and see how does it work. In most of the codes, the commands are already there to tell what it is doing. Now the this part will also be covered, most of it, in the third set, that is about the simple panel data regression, and that will be the last part of today's session, and I will try to cover it up for today. So let's start. So
Thank you so much,
now,
sir.
yes, so I will talk about the technical things, and then if you have question, do raise hand. So first of all, the library is pandas as PD, stats models because I wanted to run regression, stat models formula. So some of the regression models are in SM and some are in SMF. So you can see stat models dot formula dot API and stat models dot API. So this is within the stat models sub library, and then linear models dot panel. So I need panel OLS from there. SciPy stats, you can do regression from there because there are three types of regression that we are covering. Then matplotlib for simple graphs. So when I run it, so linear models were not already installed, so I added a linear model. So when I run it, it will load the libraries, and if it is required, it will install. So it is connecting first. When it is connected, it will start working on this. So it is initializing. Yes, it is connected. Now it will install the library. Meanwhile, I will import the data file. The data file for it is the NLS work. It is shared in the Google class. So it is saying that make sure that you don't delete because this file is temporary. So it has loaded all the libraries. When it will stop, I will move for the next step. Yes, so it has covered uh, in 25 seconds. Now we read the data file. It has loaded the data, and then we go for, we want to see the data head. So if I see the data, only 5 rows will be shown. If I want to see 20, I can just write 20 in the middle. It will show me first 20 values. So this is the data. So it's a panel data ID code here and some variables. Okay, and then if I want to see the variable names in the data file, sometimes the data variables are too many, it will not be covered in this width, so you need to see the variable names. Then I need to make it a panel data, so the command is just like in stata xt set, here data set index id code and here, and drop false. If you don't add this false, it will drop the id code and year variable. So when you run this command, it will make an index but keep the actual variable because you might need to use them to make a dummy variable. Next is, I want to run a simple regression. So pooled OLS is equal to SMF, stats models, stat, SMF was stat models formula. So is equal to OLS, and then dependent variable, curly sign, and independent variables, data is equal to data, and fit, and then print the results. When I run it, it will show me simple pooled OLS. You already know most of the things: R square, adjusted R, F test, F probability, AIC, BIC. You already know most of
Excuse
the
me,
things. Yes.
sir, a humble request. Can you please explain this table to me because I'm new to these things because I ain't
Okay.
able to understand these
Okay.
things.
Okay. So this is a regression table. It is used to see the effect of independent variables on the dependent variable. So since it is a panel data, we'll start with the simplest panel data model, that is pooled OLS. So when you run a pooled OLS, you get the intercept value and its coefficient and its probability values and dependent variables, because I've given two independent variables, age and tenure. So dependent variable is the salary and independent variable is the age of the employee, and the tenure, or tenure means experience of the employee. So there are two variables. So age is positive and its probability is zero less than 0.05, which means it is significant. This shows that age leads to increase in the salary, and the tenure also is positive, and it is where probability is less than 0. It is more than 0.05, but it is less than 0.1. So at a 10% criteria, it is significant, and it is showing that with experience salary increase, and the intercept is also positive and significant, showing that there are other factors there which also increase the salary. So R square is 10%, adjusted R is 9%, it is adjusting for the included variables. F stat is 7.83, and its p value is less than 0.05, showing the model is fit. Okay, so uh,
Thank you so much, sir.
so if you want more details, I will share some slides where you can understand the interpretation. Okay, so this
Thank
meeting
you,
is
sir.
going
Thank
to
you,
be
sir.
closed in 5 minutes, but if the our presentation is not finished by then, I will open it up again and try to conclude the today's session. Okay. So, and then extra thing in Python result is the omnibus. It shows if the residuals are normal or not. It is showing that it is not normal. It is also confirmed from the Jerk-Bira value. Durbin-Watson is showing that there is autocorrelation. Skewness and kurtosis is also showing that there is non-normality in the results. Then we want to see if there is heteroscedasticity or not. So this is stats model, stats diagnostic library. From this library, I imported a heteroscedasticity Brosh-Pagan test. So when I run it, it will give me, because Brosh-Pagan has two types of test, F test and chi-square test. So two test values and two probability values. Both of them are less than 0.05. So there is heteroscedasticity. And then I want to see the omitted variable bias Ramsey reset test. So I import the Ramsey reset test function from this library, and then when I run it, so you can see that the test value has p value less than 0.05. It means a non-linear effect is there. That is understandable, because age square or tenure square must be there, because we know that human capital theory says that with the age, when beyond a certain limit, the productivity starts to decrease and the salary will also start to decrease. Then I need to generate the residuals. This is the method, and then I want to plot the histogram. So it looks like there's some outliers here, but not that much here. So but it is looks like more negatively skewed. Then there is, I want to run the the autocorrelation test for residuals. So what I did, I generated the lag of residuals, and then residuals differences with the residuals lag. So articulation test says that if the theory says that if the residual difference are dependent variable and residual lags are independent variable, the coefficient must be negative and significant. If it is so, it means that there is no at the residuals are not non-stationary, or there is a chance that there is no autocorrelation. Means there is a convergence. Next is we want to check for correlation between the residuals and the lag residuals. So there is high enough correlation. And then we want to see, if we want to see, describe the residuals. So the mean value of the residuals is almost zero. Okay. And the median and mean are also zero. So, but they are not totally same. So it shows that there is some non-normality. Okay. Then I want to run panel data models. We start the panel data models with basic one. So when you run a panel data model and you don't know the command for panel data model, the best way is you add a dummy for cross sections. So what I did in this command, I run the panel simple pooled OLS and added the dummy for cross section. So you can see the cross section dummies. It becomes the least square dummy variable method. And then I added the wall test because there were too many dummies. I don't know how many will be there. So I did a loop to count the dummies and then add a wall test. It shows that the p-value is less than 0.05. It means the cross-section dummies are significant, means the model fixed effect should be used. And then I also ran for time dummies. So you can see same model with time dummies. And you can notice that most of them are also significant. Half of them are significant, half insignificant. You can also check for the wall test to see if they are significant. I also added an example to check a wall test for any particular variable for age, and it showed that it is insignificant, and it was also insignificant here. Okay, so wall test can be used to check for a particular variable. So we convert it into simple fixed effect model. So when I run a fixed effect, you can see there are 8 cross sections and 19 time periods, r square, r square between, within, and overall, f test, and then the results. So when you make a fixed effect model, the effect of tenure becomes insignificant. Okay, and when we run the random effect model, it also is insignificant. And in the random effect model, you can see it's shown here random effects, and it is shown here panel OLS. Okay, and then uh, if you want to compare, if you want to make a comparative table, so you can make a table jointly, like both tables, both coefficients are here and their background calculations. And if you want to do Hausman, there is no direct code for Hausman test in Python. So what you can do is in this command, what I did, I stored the beta coefficients and generated their differences, and then made a table as a covariance matrix, stored the covariance standard error from the regression and made a covariance table, and then did a chi-square distribution test just like a Hausman test, and then can generate its probability and compare it if it is less than 0.05 or above. So when I run this, it will show me the Hausman test and p-value is 1. So it is saying that random effect model should be used. So this way you can do simple tests in panel data model. Now, if you want to make it complicated and try to solve the problems, you can understand from my previous videos where I talked about how to find a methodological gap, where you can add square variables or cross products or add a dummy variables or made indices so that you can run simple models and make sure that it does not have heteroscedasticity or missing variable bias. Okay, so this way you can understand. Now, before we go to next part, so let's assume that there were problems here. So we can use advanced models. Like first model that I picked up was FGLS model. It can be used if there is autocorrelation in a simple static panel data model. So when I run this, it will run a FGLS GLS version with FGLS model. So both of them are significant. It is robust to AR1 autocorrelation, means first order autocorrelation. Okay, and if there is no autocorrelation, if there is cross section dependence, you can use the Driscoll and Cray standard errors. So it will run this model and it will make sure that it is robust to cross-section dependence. Unfortunately, panel data Python doesn't have a direct test for cross-section dependence. I am searching for the relevant library, and if there is, if I found a relevant library, I will cover it up in next week session. Then there's another model PCSE. This is used when there is heteroscedasticity because of clustering in the panel data. So we can use this to cover up the heteroscedasticity. And if the data is not normal, I also added a model for quantile regression. but there is no direct panel quantile regression model available. So I added a cross-section dummies. So I run a panel, make it a least square dummy variable based quantile regression. So this model is here. So this model is robust to non-normality. So this was the lecture for today. So unfortunately, we have a 1 minute and a half left. If you have any questions, I will try to answer it here. Otherwise, I will answer it in the WhatsApp group. So if you have any questions, you can raise hand. Yes, ask.
सर मेरा क्वेश्चन ये है कि मैं पहले काम कर रहा हूँ प्राइमरी डाटा के ऊपर।
Yes,
प्राइमरी डाटा जिसमें हम लोग पीएलएसएम यूज कर रहे हैं, आईवी डीवी मीडिएटर और मॉडरेटर के साथ। लेकिन हम लोग जब उसको मशीन लर्निंग के मॉडल्स के ऊपर रन करते हैं, जिसमें एएनएन या एसवीआर या
yes,
ग्रेडियंट बूस्टिंग जो मॉडल है, सेकेंडरी डाटा पे तो हमें उसकी वैल्यूज बताती हैं, आर एम एस सी एम ए ई और आर टू की वैल्यूज की उसकी एक्यूरेसी 90% अबव हो तो रिजल्ट अच्छा है।
yes.
लेकिन जब हम लोग उसमें प्राइमरी डाटा यूज कर रहे होते हैं तो उसकी मैट्रिक्स क्या है कि कितने परसेंटेज उसका रिजल्ट आए तो वो रिजल्ट एक्सेप्टेबल है।
सर जी जो मशीन लर्निंग मॉडल्स हैं द limitation of machine learning model is the data should be very big. So if it's a primary
ओ,
data, you should have more than 1,000 or 2,000 at least observations. And if there is more noise in the data, means the correlations are very low, and and the data variations are very low because it's. Thank you very much for listening to today's session. Because of the time limitation, it was abruptly closed. But in the next week, we covered in this session was that we've covered simple panel data regression models and basic methods to control for heteroscedasticity, autocorrelation, and cross-section dependence. In the next week, we will cover the complicated panel data models. So do join and follow the channel for more updates. Thank you.